All right, off to page number 2. We're switching from the idea of separable differential equations and getting into more of the idea of U substitution. So, although some problems are directly U substitution, which is this guy right here, I would let U be equal to sine of x plus 3. du, of course, is the cosine of x dx. For some reason, I've lost some of my highlighters, but one thing I want to notice is, see this cosine of x dx that is sitting right here? That is explicitly, let me pause this thing for a moment, okay? Let's go ahead, sorry about that, everybody, my cell phone. I hate spam calls. That was actually one that was disguised to look like a local number. I thought it was actually important. Anyway, back to our story that we had going on here. What I like to do personally is I like to look for the fact that these are exactly the same. So this cosine dx is actually specifically a du. And this is 1 over u because the sine of x plus 3 is explicitly that. And so we've got the natural log of u plus c. And of course, u is the sine of x plus 3. And I do want to be a little bit careful because in this particular instance, we should go ahead and put that absolute value on that because it would matter. So I'm kind of done with that particular question. Now, when you get to number 6, though, and I did this out of order on purpose because when people look at problems like 7, 8, and 9 sitting on a piece of paper, they're like, oh, it's U substitution. But don't forget that sometimes the smartest thing to do is literally just multiply the dumb thing out and use some very, very basic algebra. 4x squared over x squared is 4, so I just simplified. 4x over x squared is 4 over x, and 1 over x squared is sitting right here. So in this particular instance, we should know that the integral of 4 is 4x. We should also know that the integral of 4 over x is 4 ln of x. And last, if we remember that x squared is really x to the minus 2 in this particular case, the antiderivative, remember, you're going to go up one level, and then you're going to divide by that new exponent. And this is what we've got. And so you could write it this way, or equivalently, we could write it as that. And that's a good answer. Not bad. Okay, moving on to number 8. This problem, a little bit trickier. We actually did go over this one specifically in class, but if you missed that or are still a little bit bugged, I get it. What we have in this instant is something that is not identically what's sitting over here in the problem. So if I were to divide both sides by, let's say, 3, that would make this side 1/3 of a u. This side is 4x plus 1 dx. Now we're looking at 4x plus 1 dx, which is not kind of what we have. It's literally identically what we have. So all of that stuff becomes 1/3 of a du. The denominator is now a u, of course, and the numerator all disappeared because all of this was just 1 du. Now, the other little piece of the puzzle is we often like to try to change the bound so we don't have to go back to x when we're all done. So since x was 1, if we plugged it in here, you'd get 6 plus 3 plus 1. So if x is 1, then u is 10. And similarly, if you plugged in x equals 2, you'd get 24 and 6 and 1, which makes 31. So if x was 2, u would be 31. So now when we go to do our integral, evaluating it from 10 to 31, we'd have 1/3 of the natural log of 31 minus the natural log of 10. And I actually like this answer a lot. But back from math analysis, we could use the little property of logs and go ahead and express those as a singular logarithm put together. Now, for number 9, it's a little trickier. And I think most of you have a little bit of an intuition that you would think that u would be ln x. And you would be right if you thought that, because du is going to be 1 over x dx, one of those memorized facts. And what I see right here is this 1 over x dx is this piece right here. That is 1 over x dx. So that blue swath that I just made, that 1 over x dx, is going to be replaced with du. And we have 1 over u under a cube root, which again, that's okay, but it's much easier to think about that as u to the negative 1/3. And let's fix our bounds now, because I haven't dealt with that. If I plug in 1, the natural log of 1 is explicitly 0. And if I do e to the 4th, the natural log of e to the 4th is 4. That's pretty nice. And so a very difficult problem became a little bit nicer. Antiderivative goes up, divides. And in this particular instance, because the bottom bound is 0, plugging 0 into the 2/3, you're going to get 0. So there's nothing going to happen there. So my final answer is 3/2, and then we would have 4 raised to the 2/3 power. Some people like that answer, some people don't. If you want to call that 3/2, because it is, and call this the cube root of 16, we could do that as well, because 4 squared is 16. I personally feel fairly comfortable just leaving it as it was right here. Okay, our very last question on this page, number 10, will be the last one for this particular video. Kind of a trickier question. We're going to call ux plus 4. That doesn't seem all that useful, because then du is just dx. Like, we didn't accomplish that much. But because there is a binomial inside that root, it does kind of mess us up a little bit. So when we go over to here, I'm going to pull the 5 in front. I'm going to consider all of this stuff right here the square root of u, or in other words, u to the 1/2 power. The dx I'm going to replace with du, and then all that I have left that I haven't dealt with is the x right there that I just don't have it yet. That's u to the 1/2. That piece is du, but x itself is u minus 4. And although this is not going to be a pretty answer, it's still not terrible, because u times u to the 1/2 is u to the 3/2. 4 times that is 4u to the 1/2. And now we are in a problem where we can just do straight power rule. So let's let our 5 sit out in front. This is u to the 5/2 with a 2/5 in front. This is u to the 3/2. We need a 2/3 in front to make that work. And we haven't dealt with that, but if x was 3 formally, then u would be 7. And if x was 8, then u would be 12. So we're going to evaluate that from u equals 7 to u equals 12. And I do not believe that that is a particularly kind answer. Looking back at a previous version of this review, I'm not sure that I have one where I did the whole thing, but I do have it right here. I don't have a very pretty answer. So when I put it all together, if I am correct, I think I just bailed out and called it a decimal, because all of this stuff, you know, you got all sorts of square roots and raised to the 5th power. It's kind of big and nasty, gross. Hopefully I haven't made any mistakes in all of that, but I'm pretty sure I got that one right. And so that'll be the end for this section of the video, and we'll be back for the last.